In this video, we're going to talk about dot product and cross product for a vector. Okay, so let's say we have a vector A. Okay, let me assign some values. Let's say 1, 2, 3. And then I have a vector B, 2, 5, 6, for example. Okay, so how do we compute a dot product? Okay, so this is how it works, right? So A dot B, right, which is 1, 2, 3 dot 2, 5, 6. Okay, so first we take 1 times 2 plus 2 times 5 plus 3 times 6. Okay, so that will give us 2 plus 10 plus 18, right? Okay, so that is 30, right? So this is the dot product of A and B. Okay, so what other implications does this dot product give us, right? Other than finding the value 30, so what's so great about 30? Okay, so we need to know that there's a relationship between, right, the dot product, right, and the angle between the two vectors. Okay, so this is the relationship, right? A dot B is equals to the magnitude of A times the magnitude of B times cosine theta, right? And theta is the angle between vector A and B. Okay, so earlier we talked about how to find the magnitude, right? So you can refer to that video. Okay, so now we already found A dot B, which is 30, right? So what is the magnitude of A? The magnitude of A is square root of 1 square plus 2 square plus 3 square. And the magnitude of B is the square root of 2 square plus 5 square plus 6 square, right? Times cosine theta. Okay, so let's rearrange that. So cosine theta would be 30 over square root of, okay, so what is 1 square plus 2 square plus 3 square? Okay, so that should be 14, right? And then 2 square plus 5 square plus 6 square. That should give us 65. Okay, so theta would be cosine inverse of this value, right? So let's find out what that value is. Okay, so based on my calculator, it should be about 6.02 degrees, right? Rounded off to 3 significant figures. Okay, so it's a very small angle. So what does it look like, right? So I guess it should look something like this. Okay. Okay, so this is not drawn to scale, but I hope you get the idea, right? So this would be the angle theta, right? So this is the angle between them, right? The acute angle between them. Okay, so 6.02 degrees. All right, so that is what the dot product gives us. Okay, so we can imagine that, let's say if I have two vectors, okay, so if I have two vectors, let's say they are perpendicular to each other, right? Okay, so let's say this vector is B. Okay, so vector, oh no, sorry, not B. Let's call it C. Okay, let's say this is 1, 0, 0. And let's call the green vector D. Okay. Okay, so it's supposed to have underscore here. Okay, vector D is perhaps, okay, let me give a little bit more space. Let's call it 0, 1, 0. Okay, so vector C and D, right, they are perpendicular to one another, right? So you can see that actually vector C is parallel to the x-axis, right? And vector D is parallel to the y-axis. Okay, so what is going to happen when you dot both of them, right? So you get a 0, 1, 0, dot 1, 0, 0. Okay, and that will give you a 0 plus 0 plus 0, right? Which is a 0. Okay, so why is that so, right? So if you refer to the formula here, right, the relationship between the dot product and the angle in between them. Okay, so when the two vectors are perpendicular to one another, then theta would be 90, right? Okay, so let me write it here. Okay, so let's say we have a C dot D, right? C dot D would be the magnitude of C times the magnitude of D times cosine 90, right? Because the angle between C and D is 90. So cosine 90 is 0, right? So this is 0. So 0 multiplied by this magnitude of C and magnitude of D is basically 0, right? So C dot D is equals to 0. Okay, so that's the reason why if two vectors are perpendicular to one another, then their dot product is equals to 0. Okay, so if you're okay with dot product, let's go to cross product, right? Also known as the vector product. Okay, so what is a vector product? Okay, so I'm going to use A and B again, right? So let's say this is 1, 2, 3, and vector B is 2, 5, 6. Okay, so let's cross product that, right? So let's deal with the technical side first before we talk more about it. Okay, so how do we do a cross product? Okay, so I, J, K, and 1, 2, 3, 2, 5, 6. Okay, so what I'm going to do is I'm going to take A cross B. Okay, so cross product, right, for A cross B is not the same as B cross A, right? So it's not like our usual multiplication order, okay, where A times B is equals to B times A, right? So it's not the same for vector, okay, cross product. Okay, so you see why soon. So when you take A cross B, this is how we compute. Okay. Okay, so what I did here was I basically covered these two, or rather, I basically covered the first row and the first column, right? So that's how I get the 2, 5, 3, 6 here. Okay, so after I do that, okay, so this is I, okay, and then followed by minus, right? So this is always a plus, minus, plus, right? So it's alternate. Okay, so for the minus, okay, I have to cross out the first row and the second column, right? So I'll be looking at 1, 2, 3, 6. Okay, 1, 2, 3, 6. Okay, so that will be our J component, right? And followed by a plus. So the last one, I will be crossing out the first row and the third column. So I'll be looking at 1, 2, 2, 5 here. Okay, so this will be 1, 2, 2, 5, right? And this will be a K component. Okay, so what's going to happen next is, right, I'm going to find the determinant of this, right? So this is 2 times 6 minus 5 times 3. Okay, and this whole thing is for I, and similarly 1 times 6 minus 2 times 3. Okay, so this whole thing is for J, and then 1 times 5 minus 2 times 2, right? So which is 4, and that's for K. Okay, so that is basically 12 minus 15, right? So that will be negative 3i. And this is 6 minus 6, right? So that's 0. Okay, so this J component doesn't exist, right? So it's like 0J. Okay, so we can say that's 0J. And this one is 5 minus 4. So that's just k. Okay, so what does that tell us, right? So this is actually another vector. Okay, I can write it in the column vector form, which is negative 3, 0, 1. Okay, so this vector has a special meaning, right, to A and B. Okay, so it's actually a vector that is perpendicular to both A and B. Okay, so just take note of that. Okay, so this vector is perpendicular to both A and B. Okay, so when you take a cross product of two vectors, the resultant is basically the vector that is perpendicular to both the two vectors, right? So what happens if I take B cross A, right? So remember that I mentioned that A cross B is different from B cross A. Okay. Well, if you take B cross A, you will get a vector that is opposite direction of A cross B. Okay, let me just erase that for a while. This is negative of A cross B. Okay, so that's the only difference, right? It will still give you a vector that is perpendicular to both A and B, but just that B cross A is the opposite direction of A cross B, right? So that's all. Okay, so for cross product, it is also related to the angle between them in such a way. Okay. Okay, so let me write down the relationship here. A cross B is equals to the magnitude of A times the magnitude of B times sine theta times n. Okay. So theta is basically the angle between A and B. Okay, so what is n? N is the unit vector. Okay, so n is the unit vector of the perpendicular of A cross B. Okay, so in other words, after you take A cross B, you will get a vector that is perpendicular to A and B, right? And then you find the unit vector of that vector, and that is our n. Okay. Okay, so hope this video helps. Right? If it does, please subscribe and like. See you in the next video.